Okay, we are on to question number 31 and let's solve its first part. So we have to evaluate our integral. It's a definite integral. I is equal to 0 to pi by 2 and this is sine x e raised power x into sine x into dx. So we are going to use integration by parts, and for this our first function should be sine x and this should be our second function. So let me put them in order. So this is 0 to pi by 2 and sine x into e raised power x into dx. And now using integration by parts, we get I is equal to, this is first function into integration of second function minus integration of differentiation of first function into integration of second function. The whole has to be integrated. Okay, now this is I is equal to sine x integration of e raised power x is e raised power x. And for all these to be, this has to be validated for the limit 0 to pi by 2. So this is sine e raised power x integration is e raised power x into differentiation of sine x is cos x into e raised power x and evaluated for 0 to pi by 2. For this, we are going to use integration by parts once again. So I is equal to sine x into e raised power x minus, this is first function for integration by parts, integration of second, which is e raised power x, and integration of differentiation of first, which is negative sine x integration of second for 0 to pi by 2. Okay. This is now I is equal to sine x e raised power x. So opening up the bracket gives me e raised power x into cos. Negative negative is positive, but we have to multiply it with negative, so it's negative. And integration of sine x into e raised power x 0 to pi by 2. Okay, now this was our initial integral 0 I. So we can write here I. So I is equal to sine x into e raised power x minus e raised power x into cos x minus I. Okay, so I, now this becomes 2I and e raised power x is common. So this is sine x minus cos x 0 to pi by 2. And now I is equal to e raised power x by 2 into sine x minus cos x, and let's evaluate it for the limits. So I is equal to, this is e raised power pi by 2. Let's keep half out. This is sine pi by 2 minus cos pi by 2 minus e raised power 0 into sine 0 minus cos 0. Okay, so I is equal to half into e raised power pi by 2. Sine 90 is 1, cos 90 is 0, e raised power 0 is 1, sine 0 is 0, cos 0 is 1, which gives I is equal to half into e raised power pi by 2. This is 1 and this is now plus 1. So this is our answer for part A. Let's move on to part B. And for that, I will have to raise all these, or let me solve it here. So part B is 1 upon cos of x minus a. So we have to integrate, this is integration of 1 upon cos of x minus a into cos of x minus b. Okay, if you remember, this is from the NCERT textbook question. And for this, we have to multiply and divide it by sine of a minus b. Okay. So multiply and dividing this with sine of a minus b gives us, so this is I is equal to multiply and divide it into sine of a minus b. So this is sine of a minus b upon cos of x minus a into cos of x minus b into dx. Now a minus b, for this let me add and subtract x. So this is sine of a minus b plus x minus x. I have added and subtracted x to the sine a minus b. Okay, now this, I can write this as a minus b plus x minus x. So this is x minus b plus a minus x. For a minus x, if I take negative common, so this is x minus a now. So a minus b is equal to x minus a minus b plus x minus x is equal to x minus b minus of x minus a. So I'm going to replace this. So this is now I is equal to 1 upon sine of a minus b. This is sine x minus b minus x minus a upon cos of x minus a into cos of x minus b into dx. Now this is of the form sine a minus b, and sine a minus b is sine a cos b minus cos a sine b. It's cos a sine b. So let's use this identity on this. So this, when used, gives me 1 upon sine of a minus b integration. This is sine a cos b minus cos a sine b. And let's separate them for each of numerators. So this is cos of x minus a, cos of x minus b upon cos of x minus a into cos of x minus b. We haven't differentiated it yet, sorry, integrated it yet. So this gets cancelled and this gets cancelled, and finally sine upon cos is tan. So I is equal to, this is 1 upon sine of a minus b, and this is tan of x minus b minus tan of x minus b into dx. Okay, so I is equal to 1 on sine of a minus b. Now integration of tan is negative log of cos x minus b minus log of cos of x minus b. This is actually x minus a. X minus a. Okay, so this becomes sine of a minus b, and this is negative log of cos x minus b. This is plus log cos of x minus a. This is log a minus log b, which is log a upon b. So our answer for this, it should be log of cos of x minus a upon cos of x minus b. All right, so this is our answer, which is cos log a minus log b is log a upon b. So this is our answer, and let me just write it once again. So this is log of cos a upon b, and this is our answer. Okay, so this solves our question number 31, and let's move on to question number 32. So this one is done. Let's move on to question number 32.